Remember, folks, that formulas are the foundation of everything we do. So let's look at this review question. Use the true formula, you know this one, the distributive law, A times B plus C equals AB plus AC, to rewrite 3R times quantity A squared plus Y. Now, what looks funny is that the A in the problem is not the same as the A in the formula. Right? So the A squared in the problem is the B in the formula, and in fact, maybe these colors help. Maybe they're a little distracting to read, but the point is that 3R plays the role of A, and then A squared in the problem plays the role of B in the formula, and Y in the problem plays the role of C in the formula. Therefore, 3R times quantity A squared plus Y turns into 3R times A squared plus 3RY. And I know that a lot of times we don't like to think about things in terms of formulas, but if we just automatically think about distributing without relating it to the formulas here, it becomes way more challenging to do the thing that we need to do in problems that tend to grow in size. So it's helpful to take things one step at a time, and the formulas help us really be able to take things one step at a time. The whole point is the only thing that we really should be calling the distributive law has this shape of two things added together in parentheses, and then outside of that is another thing being multiplied, which the formula happens to call A. Okay, always replace a variable with the same thing everywhere. So for instance, writing 5 times quantity x plus y equals 5x plus 5k would be incorrect because it's a y somewhere and a k somewhere else, right? So the c that's in the formula was replaced inconsistently with y or k. Which is it? So technically, when you replace, by the way, you should always actually throw in a set of parentheses. This is meant to protect everything. So technically, I know this is a lot of extra writing, but technically it's 3R in parentheses times, and then in parentheses, and those parentheses are the ones that the distributive law has on one side. And then, because we replaced the b, it should be a squared in parentheses plus, and then because we replace c, it should be y technically in parentheses. And on the other side as well, where it's ab plus ac, it should be 3r in parentheses, a squared in parentheses, plus 3r in parentheses, y in parentheses. But this is really excessive, right? So we drop all of the parentheses that we can, at least by those that we can, we mean dropping all parentheses which do not end up changing what is being said on either side according to the order of operations. So the minimal number of parentheses necessary are the ones around a squared plus y, excuse me. So we'll have 3r times, and then here are the only parentheses that are absolutely required, a squared plus y equals 3r a squared plus 3ry. So technically there's all these parentheses, but so many of them can be dropped without changing the meaning. These parentheses are here to protect each substitution from what the order of operations might accidentally do to it otherwise. So these are always there, but it becomes so much to write all these parentheses that we don't tend to write them all. So what does it mean to solve for x in an equation? We'd like to review that this means to provide a list of all numbers, and only the numbers, which can be substituted for x and make the left side equal to the right side. Yeah, the actual procedure of solving an equation is different, right? We're talking about how to do it involves adding something, adding the same thing to both sides, subtracting the same thing on both sides, and multiplying the same thing on both sides. Sure, that's how. But once it's done, right, your final answer, you have apparently these things called solutions. And how does that relate to the original equation that's in the question? What that connection is. That's where we have to go to meaning, right? We have to know what's the connection between the question and the final answer, and that's what this Q&A is trying to address. So, interactive question: is x equal to 2 a solution to 8 plus 3x equals 12 plus x? Why or why not? This question can be answered without performing any actions to both sides of the equation. So I'm not asking you to take the given equation and apply processes to both sides of adding something on both sides or subtracting something on both sides. You could, but that's not the way you should think about this question. I want you to really practice and internalize what the Q&A at the very top of this slide is trying to get you to think about, right? So the hint is there. How does the previous Q&A help with this interactive question? How can you really apply what the Q&A at the top, the thing that's trying to address what it means to solve for x in an equation, how does that relate to this question that you're being asked? Is x equal to 2 a solution to 8 plus 3x equals 12 plus x? Okay, so again, solving equations, there's what it means, which is what the previous slide is trying to address, versus how to do it. Okay, it's important to address what it means, providing a list of numbers, so that when you plug in any of those numbers for x, the left side equals the right side. It's important, again, to discuss what it means, just as much as it's important to discuss how to solve. Right, there are four main operations: add, subtract, multiply, divide. These are the things that you would do to both sides of an equation. So, for instance, you might take 3x plus 4 equals x minus 1 and add 5 to both sides. And you'll see that I wrap the original 3x plus 4 and the original x minus 1, the original left side, original right side, I wrap them in parentheses. If you subtract 5 on both sides, it would, starting from the same equation, 3x plus 4 equals x minus 1, you would end up with something like this. Again, I've wrapped the original left and right side in parentheses. You multiply both sides by 5, and again, I've wrapped the original left and right side in parentheses. And if you divide by 5 on both sides, you'd have something that looks like this. By the way, in a fraction, the top and bottom are each themselves in a set of protecting hidden parentheses. Okay, so you'll notice, by the way, that the equation we keep dealing with, that the starting equation in all four of these was 3x plus 4 equals x minus 1. And there's not even a 5 on either side, but these moves are all technically valid. So it is you are allowed to add 5 to both sides, even though we don't see a 5, right? That's okay. And there's actually going to be a time very soon where we will do things like that. So I just want to get you used to this. Even though it seems, why would you ever do that? It's allowed, right? So you might say, okay, that seems strange. Why should we do it? And I get that. But we are allowed to add 5 to both sides. So the four dots here, which are showing the four operations of add, subtract, multiply, divide, whether it's add 5 to both sides, subtract 5 from both sides, multiply by 5 on both sides, or divide both sides by 5, these are all valid. Even if you might say, well, I'd never do that, that doesn't change the fact that it's allowed. Okay, so we just saw that you can add, subtract, multiply, divide by the same thing on both sides of an equation. What else? You can also just work on one side or the other. So each side of an equation, remember, is an expression. And so you can rewrite the left side using true formulas, or you can rewrite the right side using true formulas. So for example, you can use the distributive law, a times b plus c equals ab plus ac, to redo the right side of the equation, x squared plus 7x equals 5 plus 3x plus 3 root x. We might, in fact, leave on the right side the 5 plus out of it and just take the 3x plus 3 root x part and turn that into 3 times quantity x plus root x with that x plus root x in parentheses. So you'll notice here the left side was still written, because an equation, one line down, should turn into an equation, and the left side still says x squared plus 7x. We didn't touch that side, so what we just did really is we didn't do something to both sides. We just used a true formula, the distributive law, to rewrite part of the right side. So we left the 5 plus, we copied that down so that everything was all still equal in value, but we took the second and third terms, which were 3x plus 3 root x, and we rewrote that by factoring using the distributive law to be 3 times the quantity x plus root x. So we didn't change the left side at all. We only changed part of the right side. Okay, each step of simplifying an expression should be an expression, and each step of solving an equation should be an equation, right? So an expression begets an expression, while an equation begets an equation. Yeah, expression leads to expression, equation leads to equation. If you are asked to solve an equation, but you notice that your final answer is just an expression, this is a red flag. So be sure your final answer of solving for x in an equation looks like maybe x equals 7, not just 7.